Now see the sixth sum. In the sixth sum, find QP using the given information in the figure. Okay, we have to find the value of QP. This QP. So what we will do, you can see that there is a bisector here. NQ. NQ is the bisector, is an angle bisector of angle MNP. Okay. NQ is the bisector of MNP. So we can use angle bisector theorem here. So first we will say that in triangle MNP, NQ is the bisector, ray NQ is the bisector of angle MNP. Okay, NQ is the bisector of MNP. It is a bisector, so what we get? We get this PN upon NM. PN upon NM, we can say PN upon NM is equal to PQ upon QM. Okay, PN upon NM is equal to PQ upon QM. This we get by angle bisector theorem. Okay, now we will put the values in it. Now PN, see PN is 40, NM is 25. Okay, NM is 25 is equal to PQ. PQ we don't know, so keep it as it is. And QM is 14. Okay, we put the values. Now what we will do is we will cross multiply. So 40, right, PQ is equal to 40 multiplied by 14, and this 25 will come here in division. Okay, 40 multiplied by 14 and 25 will come in division. Now this we can reduce in 5 times table. 5 5s are 25, 5 8s are 40. Okay, 5 5s are 25 and 5 8s are 40. Now what we can do is, now we cannot reduce it further. What we will do, we will multiply this. 14 multiplied by 8. Multiply this first. 14 multiplied by 8. 8 4s are 32. 8 1s are 8. You get 112. You get 112 upon 5. Okay, when we multiply this, we got 112 divided by 5. So now we can divide this. 112 you divided by 5. 5 2s are 10. Get this 2 down. Again 5 2s are 10. Put a 0, put a point here. 5 4s are 20. Okay, so what we got? 22.4. Therefore PQ we had to find. Therefore PQ is equal to 22.4. Okay, so this is what we had to find, PQ. Here we got 22.4. Understood the sixth sum? Now see the seventh sum. I had explained the property of 3 parallel lines. So you can see these lines are parallel here. They have given also over here AB is parallel to CD is parallel to EF. Okay, it's given in the figure over here. AB is parallel to CD is parallel to EF. So what is given, we will write that first. AB is parallel to line, CD is parallel to line EF. Okay, since they are parallel, what we get by the property of 3 parallel lines and its transversal, we can write here, we can write this BD upon DF is equal to, see, BD upon DF is equal to AC upon CE. Understood this? BD upon DF is equal to AC upon CE. Okay, and we give a reason over here, by the property of 3 parallel lines and they are transversal. Okay, by the property of 3 parallel lines and the transversal. Now we put the values. BD is 8 and DF is 4. 8 upon 4. AC is 12 and CE is given x. That is only what we have to find. We have to find the value of x and AE also. Okay, so first we will find out the value of x. By cross multiplication, we will find out the value of x. X is equal to 12 multiplied by 4 upon 8. Okay, 12 multiplied by 4 upon 8. Now we can reduce this. 4 1s are 4, 4 2s are 8. Again, when we reduce this, 2 1s are 2, 2 6s are 12. So therefore we got the value of x. X is equal to 6. Okay, we got the value of x. Next, what we have to find is, we have to find AE. Okay, next we have to find AE. Now see AE. AE is equal to AC plus CE. Okay, AE is equal to AE. This whole line, AE is equal to AC plus CE. Now see, AE we don't know. AC, write it as it is. AC is 12 and CE was x. That means x we got how much? 6. Okay, so 12 plus 6. Therefore AE is equal to 12 plus 6, 18. Understood? So first we had to find x. After getting x, we have to add this. AE is equal to AC plus CE, that is 18. Okay. Now see the 8th sum. In triangle LMN, okay, this is a triangle and we can see this is the ray. Ray MT is the bisector. It bisects LMN. It is the bisector. So again we can use angle bisector theorem. Okay. So first we will say that ray MT bisects angle LMN. Okay, so if it bisects, what we will say, we can use angle bisector theorem. You can use this MN upon ML okay, MN upon ML is equal to NT upon LT. Okay, MN upon LM or ML is equal to NT upon LT by angle bisector theorem. Okay, by angle bisector theorem. Now you write down the values. MN is 10 and ML is 6. So 10 upon 6 is equal to NT. NT is 8 and LT we have to find out. So write LT as it is. After that cross multiply. So LT is equal to 8 multiplied by 6 and this 10 you bring it here. Okay. Now what you do is you will reduce it. 2 3s are 6, 2 5s are 10. 2 3s are 6, 2 5s are 10. Now again you cannot reduce here. So what we will do is we will multiply and then we will divide. 8 3s are 24 divided by 5 upon 5. So 24 upon 5. 5 4s are 20. Put a point here. 5 8s are 40. So therefore LT, we got the value of LT. LT is equal to 4.8. So therefore LT is equal to 4.8 units. Okay. So here we got the value of LT. We have finished the 8th sum. Now see the next sum. That is the 9th sum. In triangle ABC, again you can see this is the bisector here. They have said BD is the bisector of ABC. BD is a bisector of ABC, then that means again we can use angle bisector theorem. Okay. And first we can just write all this. In triangle ABC, segment BD bisects angle ABC. BD is bisecting ABC. So now you can use again angle bisector theorem. That means BC upon BA is equal to CD upon AD. CD upon AD. See here. BC upon BA is equal to CD upon DA. You can write here by angle bisector theorem. Okay, after writing that, write down their values. BC is given x plus 5 upon x, BA is x, is equal to CD is x plus 2 upon x minus 2, AD is x minus 2. Okay, now what you do is we will cross multiply this. That means here x plus 5, we will multiply these two, x plus 5, put it in the bracket, and x minus 2. Okay, multiplication, so put it in the bracket. These two is equal to, these we will multiply, x multiplied by x plus 2. Okay, we multiply these two, put it in the bracket, is equal to x multiplied by x plus 2. Now see this, we have to multiply. So first we will take x and we will take this whole bracket, x, and write down this whole bracket, x minus 2 plus 5, and again this whole bracket, x minus 2. Okay, what we did is, first we multiplied this with x and x minus 2, and then with plus 5, x minus 2. Okay, x minus 2 plus 5, and then again x minus 2 is equal to, your x multiplied by x, we will get x square plus again x multiplied by 2, 2x. Okay, now see here, again we will multiply these two, x into x, x square, minus x multiplied by 2, 2x, plus 5 multiplied by x, 5x, minus 5 2s are 10, is equal to x square and 2x, keep it as it is. Okay, now see here, on the left hand side there is x square, and on the right hand side also there is x square. That x square and x square will get cancelled here. Suppose this x square and this x square will get cancelled here. Now see here, minus 2x, okay, minus 2x plus 5x, minus 2x plus 5x, minus into plus, minus, so 5 minus 2 will be 3x, 5 minus 2 is 3x, sign is of the greater number only. Write this minus 10 as it is equal to 2x. Okay, minus into plus, minus, so 5 minus 2, 3x, this minus 10 I wrote it as it is equal to 2x is remaining here. Okay, 2x is left over here, so keep it as it is. Now these two x's we can get it on the left hand side, so 3x is here only, keep 3x as it is, and this 2x when you bring it on the left hand side will become, it is plus 2x, when you bring it on the left hand side it will become minus 2x, is equal to, now see here, this minus 10 is on the left hand side, we will get it on the right hand side, so minus 10 when you bring it here it will become plus 10, 3 minus 2 will be 1x, that is only x is equal to 10. See, x is equal to 10. So we got the value of x here. That is what we had to find. Find the value of x. So x, we got x is equal to 10. Okay. So we have finished the 9th sum. Now see the 10th sum. 10th sum is an activity question which is very important. In the figure, x is any point in the interior of the triangle. Okay. Interior means in the inside of the triangle, x is any point. Point x is joined to the vertices of the triangle. So these are the vertices, the corners are the vertices of the triangle. It is joined to the vertices of the triangle. Point x is joined to the vertices of the triangle. Segment PQ is parallel to DE. Where is PQ? Here. PQ is parallel to DE. Okay. QR is parallel to EF, and segment, we have to prove that PR is parallel to DF. Now these two are already given. PQ is parallel to DE, QR is parallel to EF. We have to prove that PR is parallel to DF. Okay. Now see this in the figure. In triangle, proof in triangle XDE. Now see the triangle XDE. XDE. So we have to see this triangle on the left hand side, XDE. Okay. In this triangle, and you can see here, if these two lines are parallel, then we can use basic proportionality theorem. Okay. For this triangle, these two lines are parallel, so we can use basic proportionality theorem. in triangle XDE, they have said PQ is parallel to line DE. PQ is parallel to line DE. That is given here in the question. So here we will write given. Okay. Next is, when the lines are parallel, we get by basic proportionality theorem what we get? XP upon PD. What we get here in this triangle? If these two lines are parallel, XP upon PD is equal to XQ upon QE. Okay, so here we will get XQ upon QE. That is why basic proportionality theorem, and that is your first one. Now see the next triangle which is given in triangle XFE. Okay, suppose XFE. In this triangle, they have said QR is parallel to EF. When these two lines are parallel in this triangle, again by basic proportionality theorem, what we get? Okay, XQ upon QE is equal to XR upon RF. XR upon RF. Okay, this is your second part. Okay, second one. And how you get this again? By basic proportionality theorem. So in this box we will write by basic proportionality theorem. Okay, and this is the second one. Now look at these two. What is common here? You can see XQ upon QE is common here, and here XQ upon QE, same, it is common over here. These two are common. Okay, so these two will get cancelled. What is remaining? These two are remaining. So that is what we are going to fill from here, from the first and second what we get. Okay, XQ upon QE, again over here XQ upon QE, both are common. So what is left here? XP upon PD is equal to XR upon RE. Understood? So therefore segment PR is parallel to segment DF. Okay, by converse of basic proportionality theorem. So we have finished the 10th one. This is very important. Now see the 11th sum. In the 11th sum, in triangle ABC, ray BD. Okay, ray BD is the bisector. Now see this, what we have to prove. Ray BD is the bisector of ABC. Okay, and CE is the bisector of ACE. If segment AB is congruent to segment AC, then prove that ED, this line ED is parallel to BC. Okay, we have to prove that this line ED is parallel to line BC. Now what we will do is, see in this triangle, no, I will take this first. Ray BD is the bisector. Suppose here, ABC. In ABC, BD I am taking as the bisector. Okay, first I am taking BD as the bisector. If I take BD as a bisector, what will I get by angle bisector theorem? AB upon BC is equal to AD upon DC. Understood? So first I am going to take this part. So first you write ray BD is the bisector of ABC. BD is a bisector, so what we get? AB upon BC. Okay, see here, AB upon BC is equal to AD upon DC. AD upon DC. This we get by angle bisector theorem. Okay, now see, now we will take the next one. We will take this part. When we will say, when ray CE is the bisector. Now we will say ray CE is the bisector of angle ACB. ACB. Now see the same triangle I am drawing. A, B, C. Now we are taking this as the bisector. CE. CE is the bisector. Okay, if I am taking CE as the bisector, what will I get by angle bisector theorem? AC upon CB is equal to AE upon EB. Okay. So therefore what I get? AC upon CB is equal to AE upon EB. Okay, here also we can write by angle bisector theorem. And also suppose this is your first one and this is the second one. Understood? After finding that, what we will do is, what is given over here, we can write down that. We can, what is given here, segment AB is congruent to segment AC. What is given here? Segment AB is congruent to segment AC. Okay, this we can take, we can write here that this is given. Okay, now when this is congruent, now we can say that AE, when this is congruent, see here, now AB is congruent to segment AC. When these two lines, these two segments are congruent, segment AB is congruent to segment AC. Now we can say that AE upon EB is equal to AD upon DC. We can say that therefore AE upon EB is equal to AD upon DC. Understood? And from where we get this? From 1, 2, from 1, 2, and this you can write it as 3. From 1, 2 and 3. Okay. So therefore we got AE upon EB is equal to AD upon DC. So therefore what we had to prove? Therefore segment AB is parallel to segment BC. Okay, how we get this? By converse of, this is by basic proportionality theorem. When we reverse it, this we get by converse of basic proportionality theorem. By converse of basic proportionality theorem. Okay, so we have finished this practice set 1.2. Okay, so we have finished all the sums from practice set 1.2. If you find this video helpful, please do like, share and subscribe. Thank you.